For part A, describe an experimental procedure that uses the available items and would allow the students to determine the speed v at which the launcher launches the sphere, including steps necessary to reduce experimental uncertainty. Okay. So, step 1 would be just set up everything. So, first, you would place the meter stick parallel to the paper. This is to measure the distance that the ball travels horizontally. And then second step, determine the initial starting point of the launcher. Or initial height of the launcher. Three, launch the ball. 4, record the distance traveled. And height fallen. Repeat steps 3 and 4 to reduce uncertainty and experimental or percentage error. For part B, or part B1, identify 2 quantities that when graphed will produce a straight line that can be used to determine initial velocity. So we know that for free fall, the time it takes for an object to fall is square root 2h over g, which is square root 2 times the height over g. And we know that velocity is equal to the distance over time. So we just substitute this time in over here, and we get velocity is equal to distance over square root 2h over g, which is x times g over 2h. And then to get axes, we would put x inside the square root. You get square root g x squared over 2h, which is equal to square root g over 2, which is a constant, times square root of x squared over h. And x squared over h will be your axes. So x squared for the y and h for the x-axis. What I did wrong was I kind of did like Pythagorean theorem and tried to solve out for the Vy and the Vx and then plug them into the square root. I ended with like square root 2gh plus this over here, and then it just messed up from there. Is there part 3? Oh. No part 3. Okay. Part C. Describe how the properties used in part B1. Wait, what? Oh. Identify what quantities could be graphed to yield a straight line that can be used to calculate an experimental value for n. Okay, we're giving a new scenario where the students have determined that V initial is 4.1 meters per second. They have the same launcher, and they're currently trying to determine what the horizontal distance traveled is at an angle of theta L. Okay, so part C is asking what quantities could be graphed to yield a straight line. So they give us D is equal to V initial squared over G sine n theta. And we're trying to find what axes can give us an answer for n. So after simplifying, you get arc sine of dg over v initial squared divided by the angle, or theta. What I did wrong was I kind of used formulas. I think it was 2 and 3, and I substituted a bunch of variables in, and I actually got like 1/2 arc sine of dg over v squared initial and then equal to 2 theta. So it kind of gave me like my own answer, which just didn't make sense, and it just got worse from there. Part C2 graph. Oh, plot points. Okay. Now screw this, I'm pulling out Desmos. This crap will not be drawn stale. There's no way. So you have I'll set this up like this. Oh nope, never mind for that. I'm just gonna copy and paste this stupid formula. Why does plotting points take so long? Okay, so this is data, and this is, what would the axis be for this? Okay, so 11. Hold up. Oh, 2 at 11. 23 at 10 degrees. Man, those dots are like hella hard to see. 38 at 18. $50 at 24. $62. Damn. Some scaling. Part C3, draw a straight line that best represents the data. So that's like the best fit line. Like a ruler or something. So that's probably what the graph would look like. I couldn't do this part on the private chat because I didn't solve for the equation correctly for arcsine over data. I did something completely irrelevant. For part D, what's the question? Oh, using the line draw in C and part C2 and launch speed v initial 4.1, calculate an experimental value for n. Okay, so using the formula, we just plug in okay. Using the graph, we can just set n equal to the slope, and we're given points. We're given 56 minus 14 over 26 minus 4. So that would probably be around here-ish. And around here-ish. If you were to like scale out the graph, it would be around these two circled areas where we chose our points. And then simplifying, we get we get 21 over 11. Is that right? That, which can be put as, what is that in a decimal way? 1.9. 1.91.